In this session, we will set up our first WaveQoE test. So we select WaveQoE, and in this case, we're doing wired and wireless testing. That is, we will have Wi-Fi clients and wired interface. So we'll select that. WaveQoE, the application, comes up, and we see on the left-hand side that we have WaveQoE, but we also have a set of functional tests. We'll explain those in an upcoming segment. WaveQoE contains a set of configurations of clients and traffic types that already match what's been seen in the real world at residential, university, retail, hospital, and enterprise. You can make your own as well. We'll select the enterprise and use it as an example. So the first thing we do is we connect to the chassis, just like we do in other applications. And we get the same kind of display that we do in Wave apps. And you notice that down the left-hand side here, we have a progression of steps that we will work down the page, just like we do in Wave apps. So we'll select the two cards that we're going to use. One's an Ethernet .3, one is an 802.11ac card. And since we know that this card is connected to an access point on channel 153, we'll just select channel 153. But you can see that we have the channel scanner function similar to what is in the Wave app application. And so we could have used the channel scanner to investigate what all the WaveBlade can see. But here we've got our Netgear access point on channel 153. Now the next step is we will go and set up clients. One difference that I'll point out here between Wave apps and WaveQoE is the clients in WaveQoE are the Wi-Fi clients. The Ethernet side of the equation is referred to as servers. So there will be clients on the Ethernet card. Those are Ethernet server clients. And there will be Wi-Fi clients. So in Wi-Fi, we notice that the application already has a handset, a laptop, and a PDA pre-configured here. You can add your own. You can change these. These are just a starting place. But in the enterprise, we tend to see handsets, laptops, and PDAs, so that's what we started with. As with other applications, we choose the type of interface that we're talking to, right? And that fills in information. And then for each one of these, you have a similar set of things that you can set up around security, similar to what we had in Wave apps, the PHY rate selections, and then other advanced options. In the advanced options, WaveQoE has some more options made available where you can set up the advanced MAC parameters. So if you want to emulate a client that has particular behavior around CWMin, CWMax, how it accesses the media, you can set those up here. The default means that these clients will take their direction from the access point. If you choose to set something in here, then what you're doing is programming the clients to behave in a particular way that you want. Okay, so we'll go back here and we'll choose the handset to be a legacy handset. And you notice that there is some pre-selection done for near, medium, and far. The near will turn the transmit power up and the PHY rate up. If we choose medium, it will select a lower transmit power level and a lower PHY rate, and far even lower PHY rate and transmit power level. Also, we will adjust the error rate. You can always select custom and set these to whatever you want. But the idea here is you're trying to create an ecosystem around that access point that is real life, PHY type, power level, error rates, and traffic mix. So we're trying to give you a means by which you can emulate the most realistic situation that access point is ever going to see. So we'll just choose near here. For the laptop, we'll choose it to be 802.11ac. And we'll make it 3 spatial streams, 80 megahertz, short guard interval, and enable AMPDUs. And for the PDA, we'll let it be 802.11n, and let's select it as a single stream short guard interval 40 megahertz with aggregation turned on. Again, you can go turn on power save, WMM. We've got DHCP enabled, but all of the client characteristics are then set up on the client page for those Wi-Fi clients. And you can also map those groups against whatever BSS IDs you want to. So realize that you may have multiple ports, multiple access points, and what you're doing here is you'll map these client types against every port that the application sees. In this case, we have one Wi-Fi port, so everything applies to that one. On the server page, this is where the clients are named that will be on the Ethernet card. In this case, we'll let them get their IP address directly from the system. And these are all just individual client names, but we refer to them as servers, and they're just going to be clients on the Ethernet card to source and sync traffic. The reason we do this, though, is that each one of them has its own IP address, and it may be easier for us to track and debug things later. Now let's turn our attention to traffic. There are many types of traffic that have been predefined. You can create your own. You can take one of these and copy it if you wish to make modifications to it. But there are a few characteristics that are worth looking at. One is the traffic type. You get to choose what traffic type it is. In this case, it's RTP audio. The stream control, how many packets a second, whether it's real-time traffic, the size of the payload, the traffic direction, and what server it is served to and from, whether it's IPv4, IPv6, multicast, and then this is a very important element here, the service level agreement. Each flow will be measured to a pass-fail criteria that is set by the service level agreement. So as this type of traffic is running, when we do the analysis at the end of the test, each of these flows will be measured against this service level agreement for latency, jitter, and packet loss. And if these are not met, it will be reported as a fail. For FTP style traffic, it's percent of load. Same thing for UDP traffic. That'll be latency, jitter, intended load. If it is video, it'll be a media delivery index. So what we've tried to do is to create the measurements that are specific to the traffic types and give you a means by which you can set the pass-fail criteria for each one of those flows to be measured separately. QoS can be set independently on each one of these types of flows, and the layer 337 properties, their layer 4 port numbers, and all those kinds of things. So here are many different traffic types that you can choose from, but you can also create your own. Now on the test page is where we map all these things together. First, we have similar pages to Wave Apps where we have duration. We can put information in that will show up on the PDF display. We can choose where we want the log and results directories to go, and if we need to modify the client connection process, we can do that here. In this case, we'll leave it all default. On the WaveQoE property page, there is the mapping of the traffic types to the clients and in what amount. So remember, we're doing several things all together at once here. We have 3 different types of clients. We have many different types of traffic, and here's where we can tell the application what type of traffic should run on a handset. So here we have the handset will have, let me just cancel out of that, it has VoIP traffic. The laptop has CRM style traffic, HTTP gets and posts, FTP gets and posts, when browser announcements. So these are all the different traffic types that will be attributed to the laptop. On the PDA, we have UDP traffic and SMTP traffic, right? So now we have the ability to choose what traffic will be mapped to what client device. And then here we get to set what percentage of the total traffic will be that type of traffic. In this particular view, what we do is we set a total amount of load that's going to be assigned to the access point. We show the application what percentage each traffic type represents of the total and how the traffic is assigned to a particular type of client. And then the application will calculate how many clients does it take to achieve that. So here we have 12 handsets, 12 laptops, and 2 PDAs to accomplish, and move that over here, 25 megabits of traffic distributed in the way of this table. Now I can change these numbers here, these percentage numbers. I just can never exceed 100%. So if I wanted to dial down MPEG-2 video percentage and dial up something else, I can do that. So this is a traffic balance approach. And you note here that if I was to increase this to 35 megabits of total traffic, these numbers changed. And if I go look at the mix, now I have a higher number of handsets and et cetera. So I have to create more clients in order to make that happen, right? That's the traffic mix view. Now there is another view that is also possible. If I go to the client mix mode, notice that we rearrange the information here. First, we have a certain number of clients we will assign per port. Then here we can choose those clients that have to have been defined on the client page. We can describe what traffic type or assign more traffic type to each individual client. And then we get to describe how many of those clients, what percentage of the total client count is each one of these. So if I said, well, gosh, I would like to have 4% handsets out of 100 total possible clients, I want 4% of them to be handsets, which translates to 4. I did that to make the math easy. And I'd like to see 10 laptops and 10 PDAs. There's an easy way to create a test that has 4 handsets, 10 laptops, 10 PDAs. Now I can go here and view the traffic mix to see, okay, well, with that calculation, how much traffic will this test entail? And here we can see it's 22 megabits of total traffic distributed in the percentages as shown. So there's 2 different ways that we are setting WaveQoE up. One is tell it how many clients you want and map things out from there and let it calculate the amount of traffic, or tell it how much traffic you want and let it map out how many clients it takes. So we're going to end this session with just the setup. We're ready to run the test, and in the next session we'll run the test and we'll do the analysis.